Hi, welcome back. We are in lesson 10. This lesson is in module 1. The name of the module is Introduction to Python 3 Programming. This course is delivered by Subburaj Academy. Before we proceed, make sure that you have carried out all the programming exercises as in the previous lessons. If not, stop and go back to the previous lessons. You must complete assignment 1.3. Very important. If you have not done that, please don't proceed. So we are in lesson 10. The lesson is on selection constructs of Python. Every language has selection constructs, if, else, elif, etc. So before we get into selection constructs, let us understand what is structured programming. In the early 60s, there was chaos in the programming industry. All projects were behind schedule. The cost overrun was so high, and the products that didn't have quality. The system didn't work when delivered. So this is known as popularly as software crisis. To overcome such bottlenecks, a concept of structured programming was evolved. In structured programming, control of program flow is advised to be restricted to the three structures. Structured programming advocacy was one of the recommendations for avoiding all those pitfalls I mentioned. So the two mathematicians by name Bohm and Jacob Penny proved that any computer program could be written only with the three program structures. Understand? So you don't have to have multiple types of program structures. There are only three structures are essential, and with those three you can write a program. They are: one is sequences, means you go from one sentence to another. Second is decisions. So you take decisions, and based on the decisions, you branch to different code segments. And the third is loops, where iteratively you carry out certain operations. Iteratively means basically repeatedly. It's repetition basically. So the three program structures, with these three program structures, one can write one root program. So that is essential in structured programming. In structured program, we don't use go-to statements. Python does not support go-to. It is not there. The keyword is not there in Python. The Python is really a structured programming language. So when you follow structured programming, the result is you get a program or you develop a program, you build of modules. The program is of modules, number of modules that are independent of each other, but interdependent to solve problems. So that is the goal of structured programming. So structured programming results in modular programming, a program consisting of modules. Python is, it's both a procedure-oriented language and object-oriented language. C++ is similar. So in the object-oriented language is obviously it's a structured programming language, whereas the procedure-oriented languages are not structured programming languages. You have to ensure you follow the rules so as to make programs correctly first time and every time. What is sector programming? It consists of guidelines for designing programs with built-in quality and reliability in a procedure-oriented language. That is, you have to build the quality into the programs, okay, so that you don't compromise quality, you don't commit mistakes, you don't do systems, you don't develop a program that will produce runtime errors. Okay, so we have to build quality into the program, and structure programming helps us to do that. So if the program is built in quality and reliability, the confidence of the programmer will go up. He'll feel sure that there will be no logic errors. He'll be sure of the program executing and carrying out assigned tasks. Sector program is then given to good programming practices. See, it's nothing different. If you develop the program correctly in a good manner, then it is sector programming. It is a preferred methodology in programming in procedure-oriented languages such as C. See, the procedure-oriented languages, the past languages like C, Fortran, and all, they had a go-to statement, which caused lots of problems to the users. But now that we get into the topic of the lesson, selection. So in this and next lesson, we'll be talking about selection and loops. In this lesson, we'll talk about selection, and next one loops. Basically, selection means conditional selection. Suppose you are carrying out programming, you reach a point, depending on condition, you have to select one or two or three segments of programs. That is the conditional selection. We will reserve the conditional iteration to the next session. In both cases, we check a condition. If it is true, we carry out some action. If it's false, we carry out some other action. That is condition. That is selection concept. Selection concept. To check whether the condition is true or not, Python provides relational operators, logical operators, and Boolean data types. Boolean data types are only two, true and false. What is relational operators? We check the relation between two expressions, two numeric operands. Okay. Greater than, is x greater than y? If so, it is true, otherwise it is false. For example, x is 5, y is 7. Is 5 greater than 7? No, false. If 9 greater than 7, yes, true. That is the one relational operator, the greater than sign. The next relational operator is less than sign. Is x less than y? By two outcomes possible, true or false. Then we include the boundary conditions. Greater than or equal to. Greater than sign and equal to sign. Means if 7 is greater than 7, no. But 7 is greater than or equal to 7. So we must take care of the boundary condition. We do that by two operators, greater than equal to or less than equal to. So when you want to check whether x equal to y, you have to write equal to 2 equal to 0 put in Python. Whether the x equal to y means if it both are same, then it is true. If not, it is false. Not equal to means if whether x is not equal to y. Y is not equal to 6. Y equal to 5. Okay. So these are the 6 relational operators we will be using in Python. They are very simple, very logical, very elementary also. So let us familiarize these relational operators in this session. So I have used the idle shell. So look at the first statement. I am assigning x equal to 8. 8 is assigned to x and 6 is assigned to y. I check x is greater than y. Yes, it is. So it is true. This is how we check a relationship. X is less than y. False. No, x is not less than y. X equal to y? No. X is 8 and y is 6. So you'll get false. X not equal to y? Yes, it is true. Is x greater than or equal to y? Yes, true. X is less than or equal to y? False. So these are the 6 relational operators available in Python. Operators used in the selection constructs are called logical operators. Why there is a need for logical operators? You saw in the relational operators, we checked only one condition at a time. Suppose you want to check 2 conditions or 3 conditions, then you can't do it. So that's where the logical operators help. For example, for instance, if you wish to find natural numbers, we check 2 conditions. Whether the number is positive. Second condition is whether it's a whole number. So you want to check 2 conditions to say whether a given number is a natural number. So there's a necessity for checking 2 conditions. In such cases, we use logical operators. To combine 2 or more conditions, we use logical operators. Python provides 3 logical operators and, or, and not. What is AND operator? That is, if there are 2 conditions, the outcome will be true only if both conditions are true. If any other is false, the outcome will be false. Suppose there are 2 conditions A and B. If A is false and B is true, the outcome is false. If both are true, then outcome is true. If both are false, outcome is false. So let's take an example. I have assigned 25 age, male to gender, and here is an if statement. If age is greater than or equal to 25, greater than or equal to 25, and gender equal to male, colon, premium is equal to 1000, then print premium. So look here, the if statement ends with a colon, and the next statement should start in the tab. If this is true, then the statement will be executed. Okay. So if both age should be greater than 25 and gender should be male, to get a premium of 1000. So here age is 25, so age is greater than or equal to 25, and gender is equal to male, both are true, so the premium will be 1000. The OR operator is just opposite. Here, the outcome will be false only when both the inputs are false. Let's say call it input and output. If A and B are 2 inputs and see the output, if A and B both are false, output will be false. If any one of them, A and B, any one of them are true, the outcome will be true. See the opposite. And this, if all inputs should be true to get a true outcome. Here, all outputs should be false to get a false outcome. Let's take an example. Age is equal to 30, gender is equal to female, and the condition is if age is less than or equal to 25 or gender is equal to female, premium is equal to 750. So here age is 30, so it is not, this is false. But gender is equal to female, yes, it is true. So one of them is true. So the next statement will be executed. Premium is equal to 750. Print premium. This is the outcome. Okay. So remember to type these things in the first tab because they should not be in the same place. Then it will flag error. Is it clear? So we saw AND operator and OR operator in addition to six relational operators. The third logical operator is not operator. It's just the reverse of what it is. If an input is true, output is false. If the input is false, output is true. So here we are combining with the assignments in the previous paragraphs. We are continuing here with the operators in the previous paragraphs. Okay. Actually, we had given statements in the previous slide. So those statements hold here also. The comparison gender equal to male will be false since we are prefixing it with not. Yes, look here. If not gender equal to male. In the previous slide, remember, this was not male. The gender was female. So this will become true. So premium is 1250. So this out. Okay. So the not only negates the current state. The gender equal to male is false. Not will make it true. Okay. So we have seen only one selection construct, which is if. Okay, but the outcomes true and false both we saw in the previous slides. So the three selection constructs. That's all. Only three selection constructs: the if, elif, and else. We will now discuss about their features. This is the syntax for the selection constructs. If condition one equal to true, colon. Remember, the parenthesis is not required. We can simply write if condition equal to true. Then the statements typed from here, they will be executed on the tab. You type the statements. You can type one or more or 10 statements on the tab. All of them will be executed. Elif means else if. That is, the condition one is not true. Only then we come here. Condition one is not true. Say, suppose, for example, age is equal to, age is given as 25. But here age less than 25, false. So it goes to here. Else if condition equal to true, if this is true, then this statement will be executed. So only when this is false comes here. The second set of conditions should be satisfied to execute the statement. We can have any number of elif after if. Got it? The third one is else. If none of them are true, these statements will be executed. So the statement can be one or many. The first it checks whether the condition is true or not. If false, it goes to the elif. Okay, but any case it will go to else. Else is omitted also. Else may not be there also in the program. So what are the rules? Condition statement need not be enclosed in parentheses. The statement should be terminated by colon. Statement means one or more statements on the tab, one line after another. Indentation is not optional but a must. It's not for style, but it is a requirement of the programming language. If condition one is equal to true, can be simply written. If you want to have a shortcut, you put if condition one. It means if condition one equal to true. And similarly, you can represent condition one not equal to false as if not condition one. If not condition one means the not condition one is true, which means condition one is false. Okay, this we can simplify also. These are some of the rules governing the selection constructs. There can be more elif with different conditions. The elif follows if, isn't it? It's optional again, it need not be there. Else is also not optional. The statement following if and elif and else should be typed on the next tab of the respective definitions. Remember, I'm repeating this because this is critical, otherwise we'll get syntax error. Let us now write a program to find whether a given number is positive. So this is a common statement, This is a common statement. And we are giving x is equal to minus x. Note this, x is equal to minus x. So next step, if x is greater than 0, is it greater than 0? No. All negative numbers are less than 0. False. So it will omit this statement. Okay, it will not include this because x is less than 0. And if x is equal to 0, no, it's not equal to 0, it's minus 6. Else, print negative number. See the usage of else. We are given x is minus 6. First we check whether x is greater than 0. Then we check if x is equal to 0. When both fail, we say it's a negative number. This is the result of the program. So convenient to organize programs. Okay, this is how we use if, elif, and else. Let us take another example. Here we want to toggle case. What is case? You know, uppercase, lowercase. Suppose I type lowercase, I want it to be converted into uppercase. Like for example, small a, I want a capital A. Or if I given capital A, I want a small a. So that this program does that. This is the triple quote, meaning it's a comment statement. Now look alpha. Alpha is a variable name. That's the beauty of variables in Python. We don't specify whether it's a number or character or string, nothing. So alpha input, enter an English character. This is a message that will appear. Okay. So basically, eval is not there, only input is there. So we are expecting a string. A single character is also a string. Understood? A single character is also a string. So we are checking if alpha is greater than or equal to a, small a, and alpha is less than or equal to z. So actually these values, the constant a and constant z, have some numerical values. Okay? If alpha is greater than a and less than or equal to z, y is odd over the alpha. Odd is a function which converts the where the character has got an ASCII value or Unicode value, so it converts the character to the Unicode value. Print, after this we have found it, print, suppose it is 75. Then you put char y minus 32. So 72 or 75 minus 32, you will get 53 or 43. See how it is done, because the difference between uppercase and lowercase letters is 32. So if alpha is lowercase alpha to lowercase then what you do is you get the ASCII code or Unicode code point. That's what y will be the Unicode code point of the character. Subtract 32 from that, and you get the Unicode code point for the uppercase corresponding uppercase letter. If small a, you will get the capital A. If it's small x, the capital X. Elif, if this is not, if the alpha is not this lowercase alpha to lowercase a to lowercase z, so it must be an uppercase. So elif alpha is greater than or equal to uppercase a and less than or equal to uppercase z, means is the uppercase letter. Here we are checking whether the lowercase letter. If it is false, we are checking whether the uppercase letter. If it is so, y is equal to alpha, y is equal to odd alpha. You get the Unicode code point corresponding to the character and add 32 to it. Add y plus 32. So on print. So this is how it works. Okay, if you type some rubbish, then we will print invalid character. With the program output, it asks for enter character. I typed lowercase z. I got the uppercase z. So odd and char are complementary function. Okay, the char gives you the Unicode code point corresponding to the character, and odd gives you the character corresponding to the code point. Okay, this program toggles case from lowercase to uppercase and vice versa. Then take another program, look at another program, very interesting program, to find largest of three numbers. Comment. Here, for the sake of illustration, see in Python only you can do this, you can't do it in other languages. X is equal to Y is equal to Z equal to 12. All of them are 12. If X is greater than Y and X is greater than Z, false, isn't it? They're all equal. Then if Y is greater than X, Y is also false. And if Z is greater than X and Z is greater than Y, false. So all of them are false. The print all three numbers are equal. So it prints all three numbers are equal. Okay, this is how we use the if construct to find out if and elif and else to find out the largest of the three numbers. The same program can be written in a much more professional manner using nested if and else. Then the program number is comment. So x, y, z. These are three values you are going to get from the user. The very important statement here. Eval means you convert it to number. Your input. Here I see the instruction. Enter three numbers separated by comma. Very important. You have to separate by comma. So whatever you type first will be taken as x. Comma second number taken as y. Comma third number will be taken as z. Is it understood? You have to use comma. Remember, otherwise the program will not work. Then we are checking all the if x equal to y and y equal to z. This is again very unique to Python. If the other one equal, print all three numbers are equal. Else, if they are not equal, okay, if one or two of them are different. If x is greater than y and x is greater than z, means x is the largest. And if y is greater than x and y is greater than z, y is the largest. And similarly, z is greater than x and z is greater than y, z is the largest. Suppose this is true, this will be omitted. If this is true, if this is false, and if this is true, this will be omitted. So this is a nice program for using nested if else to find the largest of three numbers. So this is the output of the program. It asks for three numbers, separated by comma. I did this. Obviously, y is the largest. We come to coming closer to the end of the lesson, where we discuss about ternary operators. So far we are writing programs here. We can write the whole program in one line. The format is like this: statement one, condition, statement two. I mean, there are three parts of the ternary operator. Okay, true statement and condition. So I will give you an example. If condition is true, then statement one will be executed. And if it is false, statement two will be executed. See, this is how you give a statement, give a condition in the middle. Okay, I'll use this. Give a statement, give a condition, give another statement. If condition is true, statement one will be executed. Condition is false, statement two will be executed. So let's take example. A result is equal to 25 percentage 3, 25 modulus 3. Means what will be? It will be 1. Print divisible if result is equal to 0, equal to 0. Else not divisible. Our answer was 1. Remainder was 1. So you have to expect not divisible as the result. So we found the remainder and accordingly we execute. See, this is all. That's all the selection construct. It selected either of the results based on one condition. The condition is the division, the modulus of 25 and 3. Okay. The next slide. You can take another example. Given A is 77, B is 22. C is A percentage B. Means A divided by 2. What is the modulus? That is 1. Print odd if C is C, else even. See, this is a condition. So the C is odd. So C is odd. So it will print odd if C. If C means if C is true. C will be true when the answer is 1, isn't it? See, the convention is all numbers greater than all non-zero numbers are true, considered to be true, and 0 is considered to be false. So if C means if C is true, it is true because C is equal to 1. So it will print odd if C is true, else it will print even. So compact. So it will print odd. So ternary operator evaluates something based on a condition being true or false. So all about conditions, all about the outcomes, true or false. Okay. It facilitates testing a condition in a single line. That's the beauty and purpose of ternary operator. So you must carry out assignment 1.3 before you proceed to the next session. That's all for now. Thank you for watching. Until we meet again. Bye bye.